So right now we're going to work on question Q. Question Q says, what is the final vertical velocity at the moment just before impact? Now, this question would be easy if this parabola was was symmetrical throughout the whole entire way. Now, the vertical velocity here when it launched was 22.4. When it comes over here, it's negative 22.4. Because it falls a little extra distance, the vertical speed this way is going to be a little bit extra. It's going to be more than just a negative 22.4. Let's take a look at it. So for question Q, now question Q is asking you, to make this question a little bit easier too, I should just tell you this. If you don't remember doing this question in class, I had you guys figure out like the initial velocity here and do this whole entire segment here to figure out the final velocity here. It took a lot of time to do that question. So to make our lives easier, I will give you the total time right now. The total flight time is an extra given I'll supply you with for the test. It's 4.54 seconds. So that should make this question a little bit easier. Now all we need is that total flight time here, plus the two pieces of information from the beginning of the whole entire parabola as it was flying freely, and it should solve for everything. So these two givens plus any other condition like this is all you really need to solve any math problem in this class. Now, let's go back to Q. Trying to solve for VFY at the end. What are your givens? You have VIY, you have AY, and you have the total time. Step 3. VFY equals VIY plus AYT. Now the initial speed in the beginning was 22.4, -10, and the time is the time is 4.54 seconds. This should give us an answer in the end. Multiply these two together, add it to that, you should get an answer of negative 23 meters per second. So it gained a little extra speed as opposed to negative 22.4 at the end, because it fell a little extra height because of the height of the cannon. That would be its final speed at the end. All right, so now for question S, it says, what is the resultant velocity at the point of impact? Now, at the point of impact, this ball has a horizontal speed of 38.7. That never really changed since the beginning of this problem. The vertical speed we just solved for is negative 23. The resultant speed is here. Now there's an angle here which we don't know, and that's what we're going to be solving in part T. Actually, I'll put it here. Part T asks you to solve for the angle at collision. All right. This angle is not equal to 30 degrees. If the ball had originally landed back at basically what would have been the vertical point of origin here, it would have been 30 degrees. However, because it falls a little extra, it's going to be greater than 30 degrees when it lands. So we can solve for both right now. Now, to make our lives easier, so for part S, I should really start off with is you're trying to solve for the resultant velocity at the moment of impact. So we're trying to solve for VF net, okay, at the end. And this is step 2, I guess, or triangle. For question T, I'll do this simultaneously here. We'll do question that's number 1. 2, it's also the same triangle that we have here. So that won't be any different. So to make our lives easier, why don't I just take this picture here and condense it into one right triangle so it's a little bit easier to use. So this would be 38.7. Okay, this would be negative 23, and this would be theta, and this would be our resultant right here. This would be our VF net. I'm going to use this triangle over here, and I'm going to use the same one over here. So let me do S first. So I'll go to step 3. The easiest thing to use right now is a squared plus b squared equals c squared. 4, 38.7 squared plus negative 23 equals c squared. C comes out to be, let's take a look, we would use 38.7 squared plus negative 23 squared, the square root of that, gives an answer of 45. So this answer comes out to be 45 meters per second. And theta, now theta we can just use SOHCAHTOA. I'll just use in this case ka. I will use AX equals RA times cosine theta. To make our lives easier, we'll put everything in absolute value brackets so that it's in the first quadrant. So step 4 on this side would be 38.7 equals, this would be 45 times cosine theta. 5. Theta comes out to be, we would do 38.7 divided by 45, and then do second cos. We get an answer of 30.7 degrees.